Thanks to the Home Depot Seeds program, we're going to be looking at the Klein Tools CL440 HVAC clamp meter. It has True RMS and a variety of symbols. We'll learn all about it next. First thing we need to do is open it up and see what comes in the box. You get one nice looking case. It's zippered. It also has a handle for hanging. Once we unzip, we get to see a manual, a thermocouple because this can read temperature. We have clips. We have flat side clips, and we also have a set of alligator clips. Very nice, a very inclusive set. We have this to help keep things dry during shipment. And then the actual tool itself, a clamp or a jaw. In both the box and the manual, it mentions True RMS measurement technology. And to simplify it, what that means is when you have a sinusoidal wave, as AC current is, when you measure that, you get your reading, right? And all multimeters and AC clamps can do a great job of that. But when there's a device on that corrupts that wave and puts irregularities into it, multimeters and non-true RMS will give you a false reading because they can't compensate for those irregularities, as can a true RMS meter. We're going to explore all these symbols, what all this stuff means. We're going to need to put a battery in it, and let's see. Yes, I was going to be a bit surprised if Klein didn't include batteries. 3 AAA batteries fit on the back. You pop the screw off so it's secure. This is built to take a fair amount of punishment, so you can drop this from several feet and still have a usable tool. Therefore, the purpose of that screw is, should this take an impact, the cover doesn't go flying off and your batteries don't go shooting across the floor, which is kind of nice. Installing the batteries, it's just a matter of unscrewing the top. It lifts right out. We insert our batteries per the diagram. Even I can make something so simple very hard. I noticed that they actually use metal in there, which is nice for the threading of the screw. So Klein Tools did not cheap out on that, which is really nice to see. And if we turn on the unit, it tells us that it's operational. It has a built-in backlight. The backlight will remain on until one of two things happens. Either you press the toggle switch to turn it off, or the device is totally inactive for 10 minutes. Those of you with multimeters may be saying to yourself, well, wait a minute, what's the difference? Because in looking at the clamp meter and my multimeter, they have a lot of the same features. And you're right. If we look at these two here, we see that this multimeter can read AC voltage, DC voltage, ohms, diode, capacitors, has a hertz capability. It even reads temperature, DC and AC current up to 10 amps, while the clamp meter can only do up to 600 amps of AC only, and even up to 10 microamps of DC and AC current, while the clamp meter can only do up to 600 microamps of DC only. So why a clamp meter? The thing that the clamp meter brings to the game is that all you have to do is insert a live wire inside the clamp area, and it will read the current of that wire without physically having to cut and put the tool in series with it, which is what you would have to do with a multimeter, which is why multimeters usually can't go beyond 10 amps. And when you stop to realize that at less than an amp you can be killed, there's a good reason for getting your amp reading without physical contact. While Klein Tools does not have a bunch of buttons and controls on its device, what's there can seem intimidating at the beginning. And for those of you who already have a Klein multimeter or clamp meter, a lot of functions will look similar, though they may be in slightly different positions. Starting off, we have the function button, which is accessible via the function wheel, and it simply turns to whatever setting you need. If there's no activity after 10 minutes, it just stops. And if you need to activate, you just move to a different position and it automatically turns back on. Looking at the next function, we see V, which tells us it's voltage. The little sine wave there tells us that it's AC. The slash with broken dashes underneath it tells us that it's DC. So this is telling us that it can read voltage, either alternating current or direct current. You may notice that when you're reading AC voltage, you also get a display of the frequency. And because it's orange, that means that this orange button will let you select between AC voltage and DC voltage. It's just a function of pressing the select button to switch or toggle between those two. Going to the next position, we have A, which is for amperage, and we only have the sine wave, so it's AC. This device cannot read DC amperage. Know that this digital clamp has a limit of 750 volts AC, 600 volts DC, 600 amps AC only, 600 microamps DC. Keep these limitations in mind when using this tool, and you should be safe. Going up from amps, we see a grouping of symbols. The one in white is continuity, which generates a tone on a closed circuit. Below that is ohms, so which of course means you're going to have to toggle to get to that setting once you put the function indicator here. There's also a reading for capacitors. Again, you'd have to toggle to that position. And if you're looking to check diodes, that's another position. So this one position has 4 functions, and you can toggle just by pressing this button and looking on the screen. There's ohms. If I toggle again, there is farad reading for capacitors. There is reading for diode, and we're back to tone for continuity. Moving up from there, we can read microamps. Now you'll notice that this is a line with dashes. In this case, the line is white, unlike down here where it was orange. So that means that this will read DC microamp without us having to do anything with this button. Above that is the setting for reading hertz. Note the percentage symbol next to hertz. If you come down to the display, you'll see your hertz on the lower screen and a percentage on the upper. Above that, we have F for Fahrenheit and C for Celsius. Again, the Celsius is orange, which means it'll be a function of pressing this button to get that particular reading. The unit is capable of reading temperatures from minus 328 degrees Fahrenheit to 2,462 degrees. But the caveat here is that your probe that's included with the kit can only go up to 356 degrees. And anything beyond that, you'll probably destroy the probe. So you need to get the appropriate probe for the temperature you're wanting to measure. Finally, at the top, we have V plus A with the sine. So we know that this means alternating current. So in this case, we can get a reading of voltage plus amperage displayed simultaneously. So what you're going to do is you're going to read current up here. On your display, it's going to show you two numbers. You're going to have your amperage, denoted here by an A, up on top, and then voltage is going to be read down here. And in order to read the voltage, you're going to have to plug in the probes so that you can get that measurement. But it will display voltage on the bottom and amperage on top simultaneously. So believe it or not, we're almost done with all the controls on this unit. What's left is something that's called range. Now this unit will auto range, which means it will decide on the number of decimal points depending on the amount of voltage or amps or ohms that it's reading. But should you decide you want to control the range, you certainly can by simply pressing the button, watch the decimal point. It will allow you to control the amount of resolution you get for that reading. Next to that, we have max and min. And what that does is it records the maximum reading and the minimum reading. Here's an example of using the max min when reading AC voltage. We have a max of 120.9 and a min of 120.5. The next button is inrush, and that's for motors, anything that takes in a high load and then normals out. So that's why this is called an HVAC digital clamp meter, because that is a function more probably used by the HVAC industry where there are lots of compressors and motors. It'll measure that inrush, which is usually very short, and most meters would just go through it and come back out, and you'd have that average reading. So this records it. It's a little bit different than max and min, where the inrush is just looking at that instantaneous increase of current that's coming through the unit, records that, then shows you the rest of what it's doing, the current as it drops down. So it holds onto that briefly so that you can see that inrush. A little different than max and minimum, where it holds a high value and a low value. This button we already know about, so we're done with that. On the side, there is a button that's called hold, and that allows you just to hold the number. Here we have a reading of frequency and voltage. I want to hold that for the client. I press the button. It holds that information. I can come over, remove my probes, and that information is retained for them to see. You'll also get the letter H indicating that it is a hold display. Let's not neglect the star of the show, which is the clamp, right? And there's a big old switch on the side for opening the clamp. And you have a wire, you open, you put the wire inside the clamp, and you may notice that there are some markings right there and there, and there's one up here. So where these line up, which is about dead center, if you place your live wire there, that's where you'll get your optimum reading. So the correct way to get a reading is to have this wire perpendicular to this surface. You know, you'll see this, depending on how much access you have to that piece of wire. But ideally, if you can get it like this, this will ensure you the most accurate reading. Which reminds me, we almost forgot about the NCV option on the orange button. If we go up here, you'll see a little place for a light, and that lamp will indicate that there is voltage present. So it's the same thing as having one of these. This is a non-contact probe that lets you know that there's voltage on a wire or in an outlet. It'll simply glow red when the voltage is detected. Likewise, this portion of the clamp, this little knobby here, if you put this up against an outlet and there's voltage present and you're holding down, this is a function that you literally have to hold the entire time. It's not a toggle on, toggle off kind of thing. That will enable this function to work, and what will happen is you'll get a light and a tone indicating that there is voltage present. Believe it or not, we're down to the last button. And it's really not a function button, it's more of a cover. To measure temperature, we set our function to temperature, and then this is really nothing more than a slide protecting the K-type input. So if you move it to the left, the slot opens up and you're able to insert your probes. There is a plus and a minus. They can only fit in one way because one blade is wider than the other. And now you can see that it's reading a temperature. It tells you that it's in Fahrenheit. If you want to change that to Celsius, we of course go to our selection button, press that, and you see that now it says C for Celsius. And you can toggle back and forth to your heart's content. By the way, that flashing is just due to the camera, and in actuality it does not flash. We finally come down to the two bottom jacks, and that's where your leads for your probes are going to plug into. The common is always black, so that plugs into there. And of course, I'm assuming that you've removed those plugs, otherwise they won't fit. And then the red one goes into the one that's labeled voltage, ohms, microamps, continuity, diode, capacitor, hertz. And this is the configuration, and it's always black on the common and red on the positive. After plugging in your leads, the first thing you're going to do is you're going to test them. Set the function to continuity with tone, bring the probe together, touch the contacts. You should get a constant tone. If you're getting a sporadic tone while moving the leads around, that means there's a break in the lead and they should be replaced. Your tone should be constant. The probes come with built-in shields that can be utilized in Cat 3 and 4 working environments. But if you're trying to work in a Cat 2 environment, let's say household outlets, you'll need to pull that shield off so that you can get the probes into an outlet so that you can get a reading. Just make sure that you reattach your probe once you're done. Otherwise, you'll lose them because there's no carrying case on the tool itself. You can always, of course, throw it into the bag. A few quick tips. When measuring current, make sure the wire is perpendicular to the loop and that it's in the crosshairs. 2, make sure to remove your leads before using the clamp to make measurements. When attempting to measure a current with the clamp, recall that it's a single wire. If you try to do something like a cable, your reading is going to be wrong because the cable will zero out to 0 amps because you have current going through and you also have ground or neutral in there. So that will zero out your results, and you need to break out the individual leads in here to get an accurate reading. And finally, when measuring ohms or continuity, make sure there is no power on the circuit, otherwise you will ruin this device. Overall, I'm really pleased with the Klein Tools CL440. Its carrying case, alligator clips, thermocouple, right-angled leads, probes with removable shields just make it a really nice set to have. And even though it's labeled for HVAC, the fact that it has a very extensive multimeter function makes it practical for home use. And a person like myself who does have mini splits and motors and some compressors that need occasional work, it's just a great all-around tool that I can use that has that built-in quality that Klein Tools are known for. So don't let the HVAC name fool you. This is a great all-around purpose tool that you'll find lots of uses for. Hope you found this video interesting and useful. And if so, give us a thumbs up, leave us a comment, join the subscription team, and as always, thank you so much for watching.